Hello friends, in today's video I am going to do some numericals based on first law of thermodynamics. These numericals you may find useful for your board exams as well as for competitive exams. So let's get started. Say this is my first question. A lead bullet of specific heat 0.032 kilocalorie per kg per degree C strikes a target with a velocity of 300 meters per second. If the bullet is completely stopped by the target, find the rise in the temperature of the bullet. Assume that the heat produced is equally shared by the target and the bullet. You may take J value to be 4.2 joule per calorie. Now here J means your conversion factor. How can you convert your calorie to joule? So let's get started. Here I am doing the solution. Now as the question says, the specific heat capacity of lead C is 0.032 kilocalorie per kg per degree C. Let me first convert it to SI unit. 0.032 into 10 cube. Since it is kilo, I have to multiply with 10 cube to convert to SI. And then since it is calorie, I'll multiply another 4.2 to convert everything to joule. And I can write joule per kg per degree C. Now you may use calculator for this calculation. So 0.32 into 10 cube into 4.2 is giving me 134.4 joule per kg per degree C. So this is my specific heat capacity. It is striking a target with a velocity of 300 meters per second. Now the bullet is completely stopped by the target. Find the rise in temperature of the bullet. So I can mention delta T is question mark. You have to assume that the heat produced is equally shared by the target and the bullet. So this question is purely based on the first law of thermodynamics, which is nothing new but the law of conservation of energy. So in this example, in this sum, the kinetic energy of the bullet has been converted to heat energy, and that heat energy is equally shared by the bullet as well as the target. So I can write here kinetic energy of the bullet is equal to the heat energy produced. So kinetic energy of the bullet half mv square. Okay, and the heat energy produced, they are saying, is equally shared by the target and the bullet. So here it will be heat energy absorbed by the target plus the heat energy absorbed by the bullet. So let's do this calculation. Half half mv square, velocity is 300 square. So let me keep it handy. Now as I know that qt equals to qb, the heat absorbed by bullet is equal to heat absorbed by target. They are equal. So actually I can write qt. Let me see the question, what they are asking. Find the rise in temperature of the bullet. Fine. So let me write here qb by 2. I'm using this equation. No, I cannot write qb by 2, sorry. I should write 2 times qb. 2 times qb, half m 300 square. So q, from the formula of calorimetry, class 10's knowledge, qb can be written as mc delta t. M is the mass of the bullet, C is the specific heat capacity of the bullet, and delta T is the rise in temperature. Half m 300 square. Clearly m and m is getting cancelled. Delta T is equal to 300 square. Oh, sorry, I did a blunder here. Your m is getting cancelled, not 2, sorry. 300 square by 4 into c. 300 square 4 into c. Let me check c value. This is my c value, 134.4. So I will substitute here 134.4. Then I'll do this calculation using calculator. 4 into 134.4, which is equal to 167.41 degrees C. This is my answer. Please see this. This is my answer, 167.41 degree C. Now let's move on to do second question. Question number 2. Let me